Hi, this is Mr. Ye. Today I would like to explain to you what's intermediate value theorem. Um, the first time math student ever encountered this theorem, intermediate value theorem, it started actually in Algebra 2. And then you will encounter again in pre-calculus. And the third time is going to be Calculus 1 or AP Calculus. So most of the students have a major confusion revolving intermediate value theorem. And even though this like third time you see it, even in calculus, students still seems like confused by it. The problem is the language of the theorem, and we're going to talk about that. And how do we use other prop to help you explain in a way that you can understand. So the prop today we're going to use is a water bottle, and this is a Zephyr water bottle, and we're going to use this to teach you how intermediate value theorem works. So we're going to put this on the side, and we're going to go back and read the theorem and write it down what's the most important thing about theorems. So I'm going to transition to the iPad screen. So we're going to read it on the right hand side. They say if f is continuous on the closed interval a and b, fa does not equal to f of b, and k is any number between f of a and f of b, then there's at least one number c in interval a and b such that f of c is equal to k. Now, for a non-math person, when you read this, it's very confusing. So we're going to try to break down as little as possible and to really, break down each small pieces. So at first, we're going to write it down. It says, what's intermediate value theorem? So let me just write it down. We're going to use the red marker here. And we're going to say, what is intermediate value theorem? Okay, so let's write down the condition. The first condition is talk about in here. In here, let's say f is continuous. We're going to say, continuous between a and b. So that's the first condition. The second condition we're going to say is fa does not equal to f of b. So we're just going to shorthand it. Fa does not equal to f of b. There's a big reason why a lot of intermediate value theorem doesn't have these conditions. And the third condition is k has between f of a and f of b. So I'm going to write down as f of a is less than k is less than f of b. So that means k is between f of a and f of b. So the result is, so this is the result, there is at least one C. So result is there at least one C between A and B such that f of c is equal to k. Now, we're going to explain to you in terms of graphing, and then we're going to use a prop to help you understand. So at first, we're going to draw an axis here. And we're going to say this is A, this is a B. Okay, now you have to know that FA does not F of B. That just means they don't have the same output. So we're going to say the FA output is right here. And we're going to say FB output is right here. And K is somewhere in between. So K could be somewhere in between FA and FB. Okay. And we had to assume that one more thing is intermediate value theorem is f is continuous between a and b. So we're going to think about the easiest continuous function that you can think of. It's probably a straight line. So we have this point right here established, a and fa and b and fb. And then somewhere along, if I have a continuous function, that means there is no asymptote. There is no piecewise function that has a breaking. So it must have to go through the value of here. At this point here, I'm going to say this is some type of C value that's between A and B that must approach passed by K. Okay, so the most important thing is to establish the proof of the endpoints, where the output of the endpoints. Then you can establish if the function is continuous, you're going to go through these points. Now, for a lot of non-math people, when you read this, it's very confusing. So we're going to use this prop here, and we're going to say this is a water bottle. Okay, so we're going to look at this water bottle, and we're going to think about all those things happening. Now, we're going to say A is right here. A is the time before I drink the water. And B is after I drink this whole bottle of water. Okay, so the time before I drink it, and the time after I drink the water bottle. Okay, so what else is that obviously FA does not equal to FB because they have different output. One is at the top and one is on the bottom. So FA does not equal to FB. And K, we're going to say this is a difficult tag right in the middle. We're going to call this as a K. It's right between the height of before you drink the water and after you drink the water. So it's right in between here. Okay. And then lastly, we're going to talk about, they say F is continuous. Well, what do you mean by F is continuous? F is continuous because water is a continuous function. There's no way for you to cut the water. So there's no way for you to cut them. So you cannot cut the water. If you turn on water faucet, you cannot cut the water. So the water you drink, it has to go through this label right in the center. And that's what intermediate value theorem means. Because if you have FA before you drink it and FB is on the bottom, you must go through if water is a continuous function. So that's just what it's saying. So essentially, it's not really difficult. So, but the most important thing is to establish where is FA and where is FB. And K has between those two values. So you have to establish that. So let's go back and talk about a question. What would a question, math question, look like in terms of this? So we're going to go down and get a couple questions from calculus exam and to analyze how do we solve the problem like this. Now, according to this question says, use the intermediate value theorem to show the equation x cubed plus 7x plus 5 is equal to 0 has a solution in the interval at between -1 and 0. So we're going to highlight this. We're going to say, well, what it means has solution. What is solution in math? Solution in math must means they can equal to 0 because that's what it's saying. This is equal to 0, so it must have x that's equal to 0. So then we're going to use this. We're going to say, how do we use intermediate value theorem? Now we're going to express that's a function. So we're going to say this is f of x equal to x cubed plus 7x plus 5. Now we're going to establish this is a continuous function. How would I express this as a continuous function? Well, very easy way is this is actually a polynomial. So when you have a polynomial function or sine and cosine function, they are all continuous functions. So this is a continuous function. F is continuous function. You have to establish that because it is a polynomial. And if it's a polynomial, they have to be continuous. The second thing is you have to establish like this water bottle. You know, when it's right here and when it's right here, it must go through here. So we're going to go back. We say, okay, let's establish that. Let's plug in the endpoint into this. And we will plug in -1 because that's a 1 to the endpoint. And we will plug in -1, so it'll be -1 to the third power plus 7 times -1 plus 5. And that's equal to -1 minus 7 plus 5 is equal to -3. So that's below the x-axis. -3 is below the x-axis. That's the output. That's below the x-axis. Now we're going to plug in f of 0, which is another endpoint. That's what we talk about. And we're going to plug in 0 in this case. So it'll be 0 to the third power plus 7 times 0 plus 5. And that's equal to 5. So obviously, when they equal to 0, that means the function must, if we travel from -3 to +5, it has to go through 0. And this is all the proof. This is the first conditions, and this is the second condition, and the 0 is between, right? So f of -1 is less than 0, less than f of 0. And that's true, so therefore it must have a one solution. Now, can it have more than one? Yes. What is the situation in water bottle? Well, you decide to drink the water and fill the water back up, and then drink the water again and fill the bottle back up, and then drink all the way the water. So that's possible. So that's just saying, at the minimum, it must go through once. You can go through more than once. You can go through 3, 4 times, 10 times, 1,000 times, for all I care. Let's go to the next one. The next one says, suppose that f is a continuous function defined by all real number x. F of -5 is equal to 3, and f of -1 is equal to -2. So we're going to say that. We're going to say, okay, at -5, at -5 is 3. At f of -1 is -2. And they also say, they already told you it's a continuous function, so you don't have to worry about that. So it must go through some value that is f of x equal to 0. But only thing that you can establish is it must be the value, the x value has to be between -5 and -1. And because they say it's continuous function between here and here, they did not say continuous function between anywhere else. So the value has to be not -7, and it's not 1, it's not 2, and it's not 0. The only one is this. And it could be happening at -2. So that's one possible point. Now, what happened after that? Well, after that, the graph could be continuous going down or continuous going up. They do not have to have f of x equal to 0, even though it's continuous. Because first you establish the top of the water bottle and the bottom water bottle, and you kind of establish that, and that's how you understand the intermediate value theorem. Hopefully to help you, because I think water bottle is a very easy way to express this, and the water is really easy to think about is a continuous function, because you cannot froze just the middle part of water and just drink the top part and drink the bottom part, because that doesn't make sense physically. And that'll be all for this crash course about intermediate value theorem. Hopefully you understand, and hopefully you know how to do that in the test. I'll see you next time.